Hello, hello, hello. Welcome everybody. Hopefully you can see me and hear me okay. If there's anybody who wants to say hi in the chat, please feel free to say hi. Welcome to our GCSE chemistry web class on electrolysis. This is our YouTube class on electrolysis. But welcome everybody. Please feel free to say hi in the chat. Welcome back if you've been to our YouTube classes before, and welcome for the first time if this is the first time that you've been here. Hopefully you can see me and hear me okay. Yeah, please feel free to say hi in the chat. We'll give it a minute and then we will get started on our GCSE chemistry web class on electrolysis. So this is one of a series of GCSE web classes that we've done on YouTube. So if you haven't managed to catch up on our previous ones, please feel free to look back through our YouTube channel, the Snap Provides YouTube channel, and you should find all of our older YouTube classes. If you haven't already, please also download today's slides. They should be in the description. That means you can follow along. It means that you'll hopefully you could then use the slides again for revision. You can make notes on it as we go along today. You can leave them blank and just listen. But the more you engage, the more hopefully you should get out of this class. So it'll be awesome to have people engaging, giving answers, making the most of having this as a live class. So yeah, if you're here, please feel free to say hi in the chat. It's lovely to have you. If this is your first time, welcome. If it's if you're an old hat, then welcome back. Hopefully everyone is doing well. I don't know if you guys have just had half term or you're about to have half term, but hopefully whichever way around it is, you're nice and chilled. Oh, Marianne, welcome. Hiya. Nice to have you here. Yeah, half term can be fun, can't it? Because you can be relaxing, but also maybe you have to do a bit of revision. Oh, Samaya as well, welcome. Nice to have you guys here. We'll give it another 30 seconds or maybe just less, and then we will get started. Oh, and apologies if I have pronounced names wrong, by the way. Shaitma, apologies if I pronounced your name wrong there. Feel free to give me what's the word? A phonetic way of saying it if you'd like. Oh, and KI Physics, nice. Hello, welcome. And Ashley, hiya. Maya, you're revising for your mocks. Oh, okay, well that's good. At least they're just mocks. Yeah, and I'm sure there will be some students who have potentially got actual exams coming up in a few months as well. So at least it's mocks. That's a good thing. Good thing that you're revising now. That's awesome. Shokmi, you've asked, is this iGCSE? So there's a lot of content that is covered in the iGCSE course. However, our web classes here are tailored specifically to AQA, EdXL, and OCR. So it's not, we don't specifically tailor our web classes for the iGCSE course, but there is a lot of crossover. So it's definitely worth staying for this. Oh, good. Well, electrolysis is a particularly difficult topic. Welcome to Duque. I'm not sure how I'm meant to pronounce that. Apologies. Welcome to Peso as well. I feel like you've been here before, so welcome back. And Nasiba as well. So a lot of what we cover in this is a higher content. Electrolysis is a really difficult topic, especially at GCSE, because there's a lot of underlying theory that you don't do at GCSE, but you just basically have to memorize a load of stuff, which makes it really difficult. So if you're a foundation student, there is content in here that you do still need to know, but there will be some content that you perhaps it isn't needed. This is supposedly year 10 content, so if you are in year 10, this should be fine for you. I will just warn you, it is a particularly horrible topic, and we are just going to do our best to get through it together. Okay, if at any point you guys have any questions, please pop it in the chat. I will try to keep my eye on the chat, and if I seem to ignore your comment or your question, please just put it again. But welcome everybody, let's get started. So this is, I'm just going to adjust my screen. So this is our GCSE chemistry web class, YouTube class on electrolysis. One of the, I think one of the hardest topics at GCSE. So just a little bit about me first. I'm Alyssa. I've been teaching with SnapProvide now for, must be a year and a half. I've been teaching A-level chemistry and GCSE chemistry for actually coming up to over 7 years now. And I have a PGCE in chemistry education from Oxford. I do all the sciences, but chemistry is my favorite. So for this session, our objectives, there's quite a lot of content to cover, so we are going to try and get through all of it if we can. If we run out of time, because I'm only going to be able to be here until about 10:02, if we run out of time, then I apologise for that. We'll just have to leave the content off the end, but we are going to hopefully understand how molten ionic compounds are electrolyzed. We're going to understand how aqueous ionic compounds are electrolyzed, and we're going to understand how to write half equations for the reactions at each electrode. What we're not going to look at is metal extraction using electrolysis. That is not covered in our web classes. It's covered in a different web class. And electrolysis using non-inert electrodes. Hopefully these words mean something to you. If they don't, we'll cover it a little bit later on, but we're not going to do that in this web class. That is not covered by us, but it is something that a few exam boards do need to know. So make sure you check if that is you. So these are the AQA specification points that we're going to be covering specifically on electrolysis. This is for AQA. Notice the cases where it's higher tier only. This is also AQA. Then this is OCR. These are specification points that we're going to be covering from OCR. And so is this one. So notice it says non-inert electrodes. We're not going to be covering that in this web class. And then this is Edexcel. And this one. Edexcel is quite nice because they do give you some examples that you should be able to use and work out. So if you're an Edexcel student, make sure you double and triple check exactly which ones are expected of you. We're also not going to be doing this one as well. This is the non-inert electrodes that we're not going to be covering in this web class. Okay, let's get started then. If you think you know an answer, whack it in the chat. If you don't think if you have got no idea, then that's absolutely fine. Feel free to have a guess though, because you may take an educated guess, and that is always a good thing. So what do we already know? So if we've got an ionic compound NaCl, what ions are present in the compound NaCl? Does anybody know what ions are going to be present in the compound NaCl? So just a reminder, ions are charged particles. They're atoms that have gained or lost electrons. Gained or lost electrons. I will probably abbreviate electrons to E minuses, so just be aware of that. E minus means electron. What have we got? Oh, lovely. Sodium ions and chlorine ions. Fantastic. Or chloride ions once it is an ion. Perfect. Okay, so absolutely. It's Na plus, Na with 1 plus, and Cl 1 minus. And that's why we've got 1 sodium and 1 chlorine, because you've got 1 positive ion and 1 negative ion, so they can match perfectly 1 to 1, 1 positive and 1 negative, to make an overall neutral or not charged compound. Lovely. What then, I've given you this time the ions in magnesium bromide. What would the formula be of magnesium bromide? What would the formula be of magnesium bromide? How many magnesiums, how many bromines or bromides, sorry, do we need to make magnesium bromide? Notice magnesium has got a 2 plus charge, bromine's only got a 1 minus. Fabulous, well done Maya, good. And Ibrahim, brilliant, well done. Good, and Mohammed, fantastic. We're going to need 2 bromines to every 1 magnesium. A magnesium atom gives up 2 electrons. Oh, and Samaya as well, well done. A magnesium atom gives up 2 electrons to become magnesium ion. So we need 2 bromines because each bromine only wants 1 electron. So in order to use up both of those 2 electrons that magnesium gives up, we're going to need 2 bromines. Fantastic. So it's got to be MgBr2. We don't actually have to put the brackets in because it's only 1 atom, but if we're using multiple polyatomic ions, ions with more than 1 atom in them, or ion in them, or element, sorry, in them, then we might want to use brackets. Okay, final one of these. What ions are present in aluminium oxide? Which ions are present in aluminium oxide? Well done, Duque as well. Sorry, I don't know how you want me to pronounce that, but hopefully that's okay. What ions are present in aluminium oxide? Don't forget to put the charges in, but yes, Maya, that looks great. Al3+, so aluminium with 3 positives, because it's got 3 electrons in its outer shell. It's in group 3. It's got 3 electrons in its outer shell, so when it becomes an ion, it loses all 3 of those electrons to become Al3+. Fantastic. And then oxygen is in group 6. That means it's got 6 electrons in its outer shell. Because it's a non-metal, it gains 2 electrons. So it's gained 2 extra negative charges, so it becomes O2-. Very good, well done, fantastic. Okay, something that you also need to be aware of from previous in the GCSE syllabus is when can ionic compounds conduct electricity? Because ionic compounds are weird, they can't always conduct electricity. Metals always conduct electricity. Ionic compounds don't always conduct electricity. When can they? When can't they? And why is this? Do we know why this is? Lovely. When molten or aqueous. Fantastic. So ionic compounds can conduct electricity when molten. Molten, hopefully, whoops, we are aware means melted. I'm going to put that in brackets, as in when they are in the liquid state. Or aqueous, aqueous meaning dissolved in water. Aqua for water. So aqueous is dissolved in water. Fantastic. So ionic compounds can conduct electricity when they are molten, melted, or aqueous. And why is this? Fantastic. Maya, that's brilliant. Yeah, well done, Mohammed. So rather than electrons, it's not the electrons, it's Peso as well, just double check. It's not the electrons that are free to move in ionic compounds. You're absolutely correct with metals, it's the electrons that are free to move. With ionic compounds though, it's just the ions are free to move. The charged particle in an ionic compound is the ion. It's the ions are free to move. Very good, Samaya as well, good. This is because the ions are free to move and carry current. Free to move and carry current. If at any point you can't read my handwriting, by the way, please let me know, because it's probably not just you. My handwriting is not great on these either. Fantastic. Okay, well done, guys. So let's have a look then at some electrolysis of molten. So this is melted, molten, i.e. melted ionic compounds. This is when we have a compound and that is it. And we've melted it and we electrolyze it. Oh, hello, welcome. Nice to have you here. If anybody else has joined and I haven't said hello to you, so Snazzy G, I don't think I've said hello to you. Welcome, welcome, nice to have you here. We are going through our GCSE chemistry lesson on electrolysis. So let's have a look at electrolysis. The first thing that we need to be confident and comfortable with is the apparatus. So first things first, I would like you to name the ions. We've got a negatively charged ion here on the left. This is a negatively charged ion. What's the name of a negatively charged ion? We've got special names for them. They are called what? A negatively charged ion is called what? Well done, Ibrahim. And Karstendia, very good. And Samaya. And Peso, fantastic. And an ion. Now, the best thing I think is to remember the ions. If you can remember how to name the ions, then we'll look at naming the electrodes in a second. But an ion, and how do you remember which is which? I remember an ion is negative. An ion is negative. Okay, it's got ion in it, so you know that it's a negatively charged ion. So those little ions down there are the negatively charged ions. And on the other side then, the positively charged ions are called what? What's a positively charged ion called? Really good, well done, fantastic. A cation. Cation, and how do we remember that one? I always remember it. A cation is positive. A cation is positive. Some other people call it positive, as if they've got pores. That's another way to remember it as well. So cations are positive. That's the way to remember which is which, an anion and a cation. An anion is negative and a cation is positive. Okay. Once we've got the ions sorted, then we can name the electrodes. Okay. So if you can remember the name of the ion, then we can remember the name of the electrode. Anions are attracted to the anode. Okay. Anions are attracted to the anode. So although the anode is positive, it's positive because the anions, which are negative, have to be attracted to it. If we remember, like a magnet, opposites attract. Positives attract negatives. So the anion, which is negatively charged, must be attracted to the anode, which is positively charged. Note that they're different charges, so the best way to remember it is by remembering the ion. Okay, if you can remember the ion, because that's the thing we use more in GCSE chemistry, then you can work out the electrode from that. So the anode is the positive electrode. Okay, and vice versa. My cathode, recognize the extra H in there, is a cathode rather than a cathode. It's a cathode, and the cathode is the negatively charged electrode, and it's called the cathode because cations are attracted to it. And in order for the cations to be attracted to the cations which are positive, the cathode must be negative, so they've got to be opposite. Oh, that's a nice way of remembering it. That's fantastic. So we've just been told that apparently in Greek, the word an means to rise up, as in it's increasing in electrons, as in it's got more electrons, so it's negatively charged. And cat means to lose, as in it's lost electrons, to be positive. I like that. That's really nice. Fantastic. Thank you for that. Okay, the other thing that we need to be able to name is, what's this liquid called? The liquid that contains the thing that we are electrolyzing, what's that called? What's that? Yeah, well done. Fantastic, Carstenida. Electrolyte, and Ibrahim, fantastic. It is the electrolyte. The electrolyte. Fantastic, good. Okie dokie. Something that we haven't actually mentioned yet, which I'll just mention very briefly now, is just if you ever want a reminder of what electrolysis is, it's given to us in the name. Electrolysis or electrolysis. Lysis means to split. And electro, obviously electrolysis or electricity. Oops, electricity. So electrolysis is splitting up using electricity. Electrolysis, splitting using electricity. Okay, fantastic. Right, let's get going with some of our definitions. So we've kind of talked through a bit of this before, but just so we've got it in writing, the electrolyte is the molten or dissolved ionic compound, the thing that we are trying to separate using electrolysis. That's what that's what is called the electrolyte, the thing that we're trying to split up. So it's the molten or dissolved compound, depending on if we're doing just molten substance or if we've dissolved an ionic substance and then we're trying to electrolyze that. That's called the electrolyte. If we're passing an electric current through an electrolyte, this causes the ions to move to the electrodes. To the electrodes, as we saw in the previous picture, to the electrodes. And in our case, these are inert electrodes. Do you know an example of an inert electrode? And are we happy with what this word inert means? What does inert mean? Does anybody know? And can you give me an example of an inert electrode? What substance do we use for our electrodes that is inert? Good. Inert means non-reactive or not reactive. Fantastic. So something that doesn't react. When we talk about using inert electrodes, we want something that's not going to react with our electrolyte. Okay. For example, graphite. You can use platinum. That is very true, but at GCSE, we tend to stick with graphite. It's a lot cheaper. So the one that if you've done an electrolysis practical, you will have used graphite electrodes, I'm guessing. But you're absolutely right, you could use platinum. It is also an inert electrode or can be used as an inert electrode as well. But graphite is the main one that we tend to use. Okay, and then we said our cations, which are positive, move to the cathode, which is negative. And our anions, which are negative, move to the anode, which is positive. Fabulous. Our ions are then what we call discharged at the electrode. Now, what that means is they are either gain or lose electrons, depending on which they need to do, to become neutral elements and compounds. So ions are discharged at the electrodes, producing elements or elements in their compounds. Okay, if anybody has any questions or anything, just drop them in the chat. Otherwise, we'll keep going. We've got quite a lot of content to get through. So I'm trying to push to make sure we get through as much of it as possible. But if you have a question, please pop it in the chat and we can address it. Okay, so electrolysis of molten ionic compounds. So this is where we have got a substance. In this case, we're going to look at lead bromide as an example. This is one that I think all of the examples have to be able to do. So it's a good one to know. If you want to learn them off by heart, obviously you can learn them off by heart. You don't need to. If you can understand the question, then and the theory behind it, then you don't have to memorize it. But if you are somebody who is maybe struggling at the moment or maybe doesn't feel like they have the reach to be able to understand it at the moment, that's totally understandable. You just need to memorize it. Okay. That's a very good question. If you do have questions and we've got time at the end, I will happily answer them. But if it could be a map about the topic that we're on at the moment, that would be more beneficial for everybody. But thank you for checking. So if we've got lead bromide, we've got a lump of lead bromide and we've melted it. It's molten. It's melted. Okay, so all we've got is lead bromide. We then stick some electrodes in, connect it to a battery so that we can electrolyze it. What's going to be produced at each electrode? So first, questions first, what ions are present in lead bromide? Lead bromide is, lead is Pb, bromine Br. So lead bromide, what ions do they form? what ions are present in lead bromide? It's a metal and a non-metal, so it's ionic compound. That's a good guess, Ibrahim, but we may have made a mistake. Double check your lead. And Castaneda as well, you're going to need to check your lead. Bromine is Br minus, definitely. It's in group 7, so it wants to gain 1 electron to get a full outer shell. But lead, actually, yeah, well done. It becomes Pb2 plus. It actually has a charge of 2 plus. Good. So lead bromide is actually PbBr2, similar to our magnesium bromide earlier. Lead bromide is PbBr2. You will need to have memorized that. There isn't an easy way to remember that one. So that will have to be memorized. But it's Pb2 plus, Br minus. So you have to have 2 bromines to every 1 lead. Okay, so we've got lead, positive lead ions and negative bromide ions. At the cathode, whoops, sorry, I pressed a button. At the cathode, if we think back, cations are attracted to the cathode, so the cathode must be negative. So which ions are going to be attracted to the cathode? And therefore, what's it going to form? Brilliant. Lead is going to be attracted to it, so it's going to form lead metal. Fantastic. At the cathode, whoops, Pb2 plus ions are attracted. They must therefore gain those 2 electrons that they lost back to form lead metal. Often in an exam, they just want you to give what is formed. So lead metal or just lead would be absolutely fine. You don't have to be able to explain it, but the question might ask you to explain it. So just read what's being asked of you, but absolutely right, well done. So the positive lead ions are going to be attracted to the cathode. So we're going to form lead metal or solid lead. And therefore, hopefully we recognize that the other way around, the anode, which is positively charged, because anions, which are negative, are attracted to it. It's positively charged, so the bromide anion is going to be attracted to it. And what's going to form? What forms at the other side? Fantastic, well done, bromide. So our Br minus ions are attracted to it. They have an extra electron themselves already, so they're going to lose that extra electron, and they are going to form bromine in the gaseous state. They're going to form bromine in the gaseous state. Well done, Thaber. That's fantastic knowledge. They will form bromine gas. Bromine gas can actually dissolve in water. So you may get some bubbles of bromine gas coming off. You may actually get it dissolving in the water as well. The point is, when you've got a molten substance, all you have to do is look at what's given to you. In lead bromide, we've got lead and we've got bromine. So those are the products that are formed. You just have to remember which one's which, okay? So, anybody, would you like to tell me? Give me a 1, 2, or a 3, or a smiley face, a media face, or a face. Let me know how confident you're feeling about that topic. Be as honest as you like. This is for you guys to recognize how you're feeling about that, as well as for me to recognize how you guys are feeling. That's absolutely fine. Fantastic. I will say, as I've said before, this is it's a great topic, but it's a hard topic. So it won't be, you're going to need to spend more than this 50 minutes just doing electrolysis, because it is hard. It involves a lot of previous knowledge as well. So make sure you're solid on your previous knowledge. How do ions form? Names of ions, bonding. If you're confident on those topics, it will make electrolysis a lot easier. Fantastic. Thank you for letting me know, guys. Brilliant. Those of you that are feeling confident with it. If you're not, that's also absolutely fine. Just maybe make a note that this is a topic you want to focus on in your revision at some point. So this time we're going to look at magnesium chloride. It's an ionic, this is an exam question, previous exam question we're going to do. Mazam, good question. Would we need to know this in more detail for higher? Yes, not more detail than we've just done, but more detail that we're going to cover. You would need to be able to write the half equations for what happened at each electrode. So how the lead ion became lead metal and how the bromine ion became bromine. So yes, you will need to know more detail, but we're going to look at how to do those later on. Good question. Okay, so with this exam question, we've got magnesium chloride is an ionic compound that can be electrolyzed. Molten magnesium chloride is in the substance. Molten, again, molten, so it's melted. So that means all we've got present is magnesium chloride in that beaker. We've got a positive electrode and we've got a negative electrode. This question says, justify the production of magnesium metal at the cathode in experiment A. So this is the kind of question that you are that you might need to answer. Definitely if you're in higher, 100% you'd need to be able to do this. This may be one of the questions that would be at the end of a foundation paper. They probably wouldn't phrase it like this. This is aimed at higher ability because one of the 4 marks would be to write the equation. So let's have a look. Justify the product of the production of magnesium metal at the cathode. So if we just flick back to here, we've got magnesium chloride. Magnesium is Mg2+, chlorine Cl-, so magnesium chloride as a substance would be MgCl2 as we've looked at previously. So we're going to have Mg2+ and Cl- in solution. The cathode is the negatively charged electrode because positive ions are attracted to it. And then just so that we've done it completely, our negative ions would be attracted to the positive electrode. So our cathode is our negative electrode. So how, why do we form magnesium metal at the cathode? Well, because our magnesium ions are attracted to the negatively charged electrode, which is the cathode. Good question, Mazam. Let's see if we can answer that. Why is it Mg2+? Why is it Mg2+? Let's put that in actually, Mg2+. Good, well done, D. Magnesium is in group 2. That means it has 2 electrons in its outer shell. So when it wants to become an ion, it wants to lose both of those electrons. The reason that our elements become ions, the reason they react to become ions is so that they have a full outer shell. Well done, Samaya. And in order to do that, they can lose their 2 outer electrons. That means they have, they still have a full shell of electrons underneath. So they are much more stable. That's why they do it. Brilliant, well done. Yeah, fantastic, guys. So it's Mg2+ because it's lost those 2 outer shell electrons. Electrons are negatively charged, which means it now has more protons than it does electrons, so it's positively charged. If this is something that you struggle with a bit, it might be worth, like I said, go back and double check structure of the atom, bonding, formation of ions. All this content is knowledge that you unfortunately you need to have in order to succeed in electrolysis, which is, you know, one of the reasons why it's so difficult. Okay, so we've got magnesium ions, our Mg2+ ions, are attracted to the negatively charged electrode, the cathode. How do they become magnesium metal? Mg2+ needs to become Mg on its own. Magnesium ions need to become magnesium on their own. So now we've got to reverse that ionic process. Before, magnesium lost those 2 electrons to become a magnesium ion. So how does it get back to magnesium metal again? Yes, we do, Duque, sorry, we do need more than that. Good, we need to gain those 2 electrons back again to become magnesium metal, neutral, well done. So it's got to gain 2 electrons to become magnesium. So let's put that into words. Yeah, well done, Mohammed, fantastic, really good. So our magnesium ion gains 2 electrons. Let's try and spell that properly. Electrons to become elemental magnesium metal. So I think this would get us our 4 marks. I will just double check. So magnesium ions are attracted to the negatively charged electrode. That's 1 mark. The magnesium ion gains 2 electrons to become elemental magnesium metal. And then we've given an ionic equation as well. Fantastic. It is reduced as well. You can say reduced instead of gaining 2 electrons. You can say it's reduced. That would work as well. It is oil rig. Fantastic. If you know oil rig, we're going to cover it in a couple of mins very briefly anyway, but really, really good. What else have we said? Does the battery play any role in terms of plus and minus? Good question. Let's just have a quick look here. So in this case, our cathode is the what we would call the negative electrode, and our anode is the positive electrode. Okie dokie, no worries. Thank you very much for being here and for contributing. If you put the battery the other way around, the electrodes would just swap. So in this case, we might have the positive side and then the negative side in that way around as my power supply. But if I were to swap them around, so if I were to put the battery the other way around, then the electrodes would just swap, and that would just mean that electrolysis would happen in the other direction. It's a very good question, but in terms of electrolysis, it doesn't matter. Which is positive and which is negative is dictated by which way around you put the battery in. So very good question, but yeah, they would just swap places. Okay, let's keep going because we are running short on time, and we might have to skip the next exam question, I think, just to make sure that we can cover everything or as much as possible. So this time we're looking at aqueous solutions. So this is where it gets a little bit more complicated, and there are some rules that we need to memorize. I will talk you through why, I'll talk through the theory, but if you are if you aren't as confident with your theory, then it may be worth just memorizing these rules. So in aqueous solutions, water is present as well as the ionic compound. We've taken our ionic compound and we've dissolved it in water. So that means we've got our ionic compound and water in the solution. Now, water, one of the reasons it's so awesome and is vital for life is because it breaks down into H+ and OH- ions. Okay, just note this is something that students often get wrong. We often remember that it's H+ ions, very good, but the other ion is OH-. If you think we've got H2O, water, which is one oxygen bonded to 2 hydrogens. So what we actually do is break the compound in half. So we've got 1 H+ and 1 OH-. Okay, so just remember that it's not an O-. It doesn't break down into O2-. It breaks down into H+ and an OH-. So that means if you've got an aqueous solution of NaCl, so we've got sodium chloride dissolved in water, what ions are going to be present? Anybody want to have a go? We've got aqueous solution, so that means it's dissolved in water. Which ions are present? Is it a redox reaction? We wouldn't describe it as a redox reaction, but I guess you could talk about redox reactions occurring when you electrolyze it, because there is both happening, potentially. Good, well done, guys. So we will have our sodium ions, Na+, and our Cl-, but because we've also got water present, fantastic, DK as well, we've got H+ and our OH-. So there's actually, because this is ions in solution, this is ions dissolved in water, we've got 4 different ions present in this case. Really nice, well done those of you that got that, that's awesome. Okay, we've got our sodium chloride, our ionic compound that's split into its ions, and we've got water that's split into its ions. So that means that all of these are present in my beaker floating around. And that means that the products at the electrodes are different or can be different. So let's have a look at those rules that we need to know to decide what the product is. So the ions that are discharged when an aqueous solution is electrolyzed depends on the relative reactivity of the elements involved. What that means is these 2 rules, which we need to memorize. The product that's formed at the cathode at the negative electrode it's either going to be, if we look at our previous slide, it's either going to be our hydrogen, which is positive, or our sodium, which is positive. Now, we have to look and compare those 2 elements. The product that's formed at the cathode will be hydrogen if the metal is more reactive than hydrogen. This is where we have to bring in another part of our chemistry GCSE and try to remember the reactivity series. Brilliant, well done, Samaya, exactly right. So the product that's formed at the cathode is hydrogen, i.e. H2, if the metal in the solution is more reactive than hydrogen. So we'll look at our previous example in a second. The other rule is the product that's formed at the anode at the positive electrode is going to be oxygen unless there is a halide ion present. Halogens, the halogens are group 7. Hopefully we know that, group 7 element. So the product that's formed at the anode will be oxygen unless there is a group 7 element present, then it will be that element. Then, oops, let's rephrase that then, the halogen will form. The group 7 element will form. Nice, well done. How do we know if a metal is more reactive than hydrogen? Yeah, because of the reactivity series. So it's something that you may have a quick Google and get it up in front of you. I'd use the BBC bite-sized version if you've got quick access to it. But you should have the reactivity series. And if you learn the one which has got carbon and hydrogen in it, it's easier. Even though carbon and hydrogen aren't metals, and we tend to call it the metal reactivity series, we use carbon and hydrogen as references quite a lot at GCSE chemistry and being going on. So it's good to learn. That is fantastic. That's really good, Dee. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. That's awesome. So P for potassium, S for sodium, C for calcium, M for magnesium, A, aluminium, C for carbon, I presume, Z for zinc, I for, go on brain, iron, T, what's your T going to be? I'm not sure which T you've got there. Or the L, which T and L are you using? I'm not 100% sure. But anyway, if you can get one of those, learn it, then you'll get the reactivity series in your heads, and that will help with this as well. Okay, so let's apply these rules then to the compound that we just looked at. So in the electrolysis of aqueous sodium chloride, aqueous meaning we've got water present, and sodium chloride is our ionic compound. What product is formed at each electrode? So the ions present, we've already said, are H plus and OH minus. Oh, tin and lead, of course, sorry. Yeah, good thought, well done. Note, you don't have to know the full reactivities, metal reactivity series at GCSE, you only need to know condensed one. So if you are somebody that doesn't like learning things, like me, don't feel like you have to learn the whole thing, only learn the shortened version. Good, so we've got H pluses and OH minuses from water, and we've got Na pluses and Cl minuses from sodium chloride. So at the cathode, fantastic, Zoeb, our H2 is more is going to be formed because our sodium is more reactive. Na, sodium, is more reactive than hydrogen. So H2 is going to form. That's as per our rules on the previous slide. H2 is going to form. And then at the anode, again, thinking back to our rules, oxygen is formed unless there is a halide present. There is a halide present. So our halide is going to form. The anide is a halide. So chlorine, the halogen, is formed. Fantastic. Really, really good. Well done, guys. Very, very good. I've just realized I'm going to have to skip back. Just go back to this slide because I've realized I read my notes and I've said something wrong. It would not be aqueous bromide. Apologies, I've got aqueous bromine written down here, but it wouldn't be aqueous in this case because this is molten lead bromide. There's no water present. So I'm really sorry, I've just registered that in my brain. It's not aqueous bromine formed here because there's no water present. It would just be bromine in the gaseous state. So apologies for that, guys. Just make that note. Okay, let's flick back. How are we doing for time? Ooh, we need to finish in a second. Okay, we're going to do this final, a final tiny bit of theory, and then I'm going to have to disappear. So I'm afraid we're going to have to miss out this exam question because we don't have time for it. So we're going to super quick just do our half equations for electrolysis. Hi, Shahani. There will be a lot of content in here that is appropriate for the Cambridge exams. However, we don't focus on the Cambridge exam, so there may be content missing. Okay, so feel free to stay here, but it may not be. You will need to check with your specification how much of it crosses over. Okay, so halides are ions of the halogens. At an anode, it's oxygen that's formed unless a halide is present. Okay, just so that you are aware, it's oxygen is formed, oxygen gas, O2, unless a halide is present. Yeah. Okay, so electrolysis and redox. So this is looking at our redox we were chatting about earlier. In electrolysis, oxidation or reduction takes place at each electrode. Oxidation is loss, reduction is gain. Hopefully you guys know that one, oil rig. Oxidation is loss, reduction is gain. And this is of electrons. Of electrons. So oxidation is loss, reduction is gain of electrons. So oxidation, which is loss of electrons, takes place at the anode, which is positively charged, the positive electrode. So loss of electrons takes place at the anode as negatively charged ions, our anions, which are attracted to the anode, lose electrons. and vice versa, reduction takes place at the cathode, which is the negative electrode, as our positively charged my pen's being slow, ions, our cations, gain electrons from the negative electrode. Our electrode's got to be negative so it can give electrons. Okay, we just need to be aware of which one's which. And the final thing I'm going to say before I disappear, because I'm going to need to switch over onto the A-level class, is this final thing on doing half equations. Yeah, Castanidar, red cat and anox is a nice way of remembering it. Picture a red cat. So reduction at the cathode and the anode is oxidation, red cat and anox, that works. Is a good way of remembering it. That's just for electrolysis at GCSE though, it does change and is a little bit more horrible at A level. So we can use red cat and anox for GCSE, but not at A level, unfortunately. And you can say negative is attracted to positive, definitely. That's how we know which one they go to. Yeah, exactly right. Okay, so half equations. If we need to write a half equation, let's have a look at a mean, horrible example. So write the half equation for the reaction at each electrode when sodium sulfate solution is electrolyzed. So I'm just going to give us these ions because we don't have time to work it out, but please feel free to just double check you're confident with it. Sodium sulfate is Na2SO4. So sulfate is SO4 2-, so we're going to need 2 of them to get our sodium ions, and it's in solution. So there's also waters. So the ions present must be our sodium ions, our sulfate ions, our H pluses, and our OH minuses from water. Those are the 4 ions that are present in sodium sulfate solution. The solution means it's aqueous sodium sulfate, it's dissolved. So at the cathode, if we think back to our rules, at the cathode, hydrogen is formed unless the metal is, or hydrogen is formed if the metal is more reactive. So the metal, sodium, is more reactive than hydrogen, so hydrogen is going to be formed. So that means we need to make hydrogen. How do we make hydrogen? Well, we've got to get our H pluses, and we've got the H pluses have got to gain electrons, but there's 2 hydrogens here, so we're going to need 2 H pluses and 2 electrons to make hydrogen. And then our other rule at the anode, oxygen is formed unless there's a halide present, but there isn't a halide present in this example, so oxygen is formed. So we know we're forming oxygen. Again, there's 2 of them. So we're going to need 2 things containing oxygen. So actually, in this case, it's our OH minuses that contain oxygen. So our OH minuses, we're going to lose, in order to form O2, we actually form O2 and water, and we form 2 waters because we've got to have, because we've got to get rid of the hydrogen somehow. So we actually need, no, we don't, we need 4 of those. We need 4 OH minuses, and we actually end up losing then 4 electrons, and we produce 1 O2 gas molecule and 2 water molecules. It's hard work, this is, and this is definitely higher tier stuff. You wouldn't be expected to write half equations at foundation level. It's super, super hard. These ones are not so difficult if you can spend the time to work them out. It's the anode ones which tend to be a little bit harder. Okay, right, sorry guys, I'm going to have to disappear because I'm running out of time to get ready for my A-level class. So we've looked at how molten ionic compounds are electrolyzed and how aqueous ionic compounds are electrolyzed. And we've very briefly, I'm sorry, it was not as long as I'd like to spend on it, we've looked at how to write half equations for the reactions at each electrode. So just a reminder, we've got an upcoming web class for maths. So if you're interested in GCSE maths, make sure you pop that in your diary and get a reminder on YouTube. But otherwise, have a lovely rest of your day, guys. It's been fantastic having you here. Thank you for being so interactive. And I'm going to have to disappear now and hop over onto the A-level. So if you fancy joining us for a bit of A-level chemistry, then pop over onto the A-level Webclass. Okay, but thank you so much. You've been absolutely awesome. And I will see you guys very soon. Thank you, guys. Thanks, guys. Well done. Have a lovely rest of your afternoon. Bye, guys.